So what we're going to talk about today is the installation simulator here. What we have hooked up in the setup is a FieldFox VNA running about 18 gigahertz broadband. We've got the phase flex cables hooked up to it. We're going to be testing our new airframe cable, called it GORE-FLIGHT 6 series line, derivative of our old GORE-FLIGHT series, except 40% lighter. So oftentimes when you take out weight, people say, it's not as rugged, something's probably changed in it. What we're going to show you is that it can survive the installation simulator, which essentially was designed from feedback from our airframe customers who said they're seeing cables fail during airframe installs. So this is the third time this cable's been run. We ran it yesterday, we ran it this morning, and we're going to run it again through here. That being said, why do we do this? We hear the cables fail frequently. 75% of microwave cables are being replaced here. So about 1/5 of all microwave cables are replaced multiple times a year. So what do we do about that? Well, we design before we ship product to make sure that our cables don't fail. Feedback says, oh, you guys are expensive, but we last. You know, the cost in the end is probably cheaper. The aerospace industry specifically says that they want cables to last for the lifetime of that aircraft. However, the feedback is that 64% of these airframe cables are failing at some point in the lifetime of the aircraft or of the system. 41% of these cable assemblies are having some amount of failure during install of the respondents that replied to the survey. We'll take a look at some parameters that you may measure in a lab setting of trying to guarantee that the performance will survive in the field. So what we look at is loss stability, amongst other things. After some tick-tock testing of our assemblies, we took a look at how we compare to some of the alternatives in the industry. As you see on the graph, broadband through 18 gigahertz here, we have only about 0.2 dB of change here. Meanwhile, the alternatives, much higher. One, you see complete failure. The other, even more worrisome, you see actually some gain. That means when you're testing your DUTs, you're actually getting some sort of false negative where maybe you were failing this, but that extra dB of gain around 18 gigahertz is making it look better than it actually is. It didn't move. There you go. There's a graph. That's why I had to look behind me. So in the aerospace industry, what we did was design the installation simulator to check on this. It's got several features. Jay will talk about them as he goes over them. We got mandrels here. We got some pulleys and an abrasive offset edge. What we did was we looked at the insertion loss before and after installation into this. As you can see, our curve after installation is very smooth broadband attenuation, very controlled. The alternative has developed sort of spikes past 6 gigahertz, and it's essentially useless. It belongs in the trash can at this point and is unstable. When we try to look into more of why this cable looks like that in insertion loss, we take a closer look at VSWR and add our time domain data. So the VSWR of the GORE cable after install is still very smooth, very controlled through 18 gigahertz below 1.2 with direct launch TNCAs on it. Missed one. When we take a look at the alternative, we see very high spikes above 2 to 1, which is creating that instability that you saw in the insertion loss curve. When we look at why this is happening, we look at the core of the cable. You got your center conductor, your dielectric, and your outer conductor. These are what we're trying to protect. These are what are defining your electrical performance, your phase match, your insertion loss. All of this is critical to the system. The additional layers are trying to protect that. And we do it in two different ways. One way is the airframe way, and one way is the test cable way. So if you're flying, you're going to want the airframe side. If you're in a test lab, you're going to want the test lab side. Or if you're on a flight line too, you probably want the test lab side. But if it's flying, you're going to want that reduced weight, you're going to want the vapor seal layers. And I'll quickly go through some of these layers here. You got a braid over top of that, an extra mechanical strength. We got a vapor barrier on our airframe cable. Importantly for these applications, we have our crush membrane, 75-pound per inch or greater for the GORE-FLIGHT, and 250 pound per inch of crush protection on the face flex. So much more rugged, can survive tens of years of use in lab environments. We've got a few more extra layers here, and then an abrasion resistant jacket. That'll resist the scraping of the edges, the scraping against sharp edges, whether it be in lab or whether it be in an airframe installation. With that being said, I'm going to throw it over to Jay, and Jay's going to set up this test here to be run.
Yeah, so if you want to put that on the screen,
yeah,
I'll set this up. So the data that you're going to see from Chris when he puts it up on the screen. So
yeah,
like he said, this assembly right here has been through 2 complete cycles at this point, and so this will be the 3rd cycle. Once he displays it, I'll show you what we're looking at, but we're still under 1.2 to 1 in VSWR. So I'll go ahead and store that.
So Jay's storing the traces here into memory, and we're going to display both data and memory so that you can see what it looked like before installation and then after a mock installation in an aircraft. And we have Jay run this through because, if you'll notice, it's about 40 pounds to pull this thing through the installation simulator. And he's going to pull it by the connector. We're not using any sort of adapter. He's just going to grab the end of the cable. He's going to pull it by the connector through all these features that are detrimental to the cable assembly. If you recall, you saw what the alternative looked like after it got ran. Just as a reminder, this will be the 3rd time this cable goes through here. So we ran all our qualification on 3 cycles of this. So this will be the end of the day for this cable.
Yeah, so as I run this through, I'll try and explain, just from talking to the end users, typical things you might see on an aircraft. The first station is just a simple conduit we might be pulling through. The second station is also, and then maybe a reverse direction. So then I'm coming under here to these pulleys, which will actually be the minimum bend radius on the cable that the cable's set up for. This particular cable has been qualified for 1.5 inch minimum bend radius. So we're not only putting the minimum bend radius on the cable itself, but I mean, you can see we're basically pulling that across the entire cable. You got that simulator? Okay. So that's a fairly rugged install, probably more than you'll see in most installations. I'll go ahead and hook that back up, and we'll see how it compares to that data.
So what we're going to be looking for here is a smooth insertion loss curve, showing that nothing has happened mechanically to the layers that we've been trying to protect. Everything from the center conductor, mainly I guess the outer conductor, making sure that there's no dents, there's no discontinuities in that outer conductor. So very controlled visual still, and very smooth insertion loss curve is really the highlights of this cable assembly after it's been run. Also, being the 3rd time it's run, it's kind of leveling out in the insertion loss. The outer conductor is allowed to stretch; it's helically wound. However, we're making sure there are no gaps. So, as you see, it lays right on top of what it was before we did it.
And also, if anybody's interested, as Chris said, so the original cable assembly right here, we have 2 10-foot lengths. And the newest cable right here is now 40% lighter than the original cable. So if you're interested, come on up here and check it out. You can come up and check out the cables or anything you'd like to do, or if there's any questions right now, we can answer those.